Welcome everybody. In this tutorial we're gonna add some cool effects to a game using shader graph. You can write HLSL code to create your own shaders, but you can also use the graphical interface, which comes with over 200 nodes. These shaders are based on ones I found online or completely created by myself, and all put in one project, free to use. We're going to create a shader from scratch, but first we'll walk through the shaders in the project. This shader will give you a nice disco effect on your character. This is a toon shader you can use to create cartoon style games. And this is an outline shader, which gives an outline around your model, and you can use it to select things at real time during your game or application. This script, what's doing this is also setting the material at real time. This is a glow shader, which will make your objects glow, and this is a bubble shader, which creates a bubble around an object. And also note the refraction of the light. This is a force field shader, which creates a force field around your objects. You can use it in a game. And this is the default UOP lit shader again. This is the twirl shader, which gives a twirl effect to your textures, and this gives you a disco kind of effect. This is a glow shader, which makes your objects glow, and this is what I call the extrude shader. It's a vertex shader. It manipulates the vertices. It extends the normal, and by doing that it makes the object kind of bounce, and you can use that, for example, to make something shake without shaking the whole model, but just shaking a part, and without moving it out of its own position. This is a billboard shader. Observe the tree. The tree on the left is using a usual unlit shader, and this one is using the billboard shader. It's always rotated towards the camera, and that's really nice for objects like trees. This is a snow shader, which creates gradually snow, so you can make a snow world and slowly make it disappear, for example, to have weather effects in your game. This is a waterfall shader, which creates some kind of a waterfall effect on a texture. This is a laser shader, which uses visual effect graph in combination with the shader to create this effect. So we use particles and also a shader to make the beams like this. This is a water shader. Water is very common to have a custom shader. You can see that the water is also bouncing a bit. That's also done by the vertex shading. And we have the caustics on the water. And finally we have the visual effect shader, which gives us some fire. And now let's create our own shader. I've already created an environment, and we will create a quad here. And on this quad we will display the waterfall. Therefore, first we're gonna create a material. Let's call it math waterfall, and we're gonna create a shader with shader graph, URP, lit or unlit, it doesn't really matter. let's call it waterfall shader, and let's open it. You see that we've chosen the lid. You can change it afterwards if you want. By the way, this waterfall shader can be unlit. You'll see that some of the properties now disappear. They are not needed for unlit shaders. The shader consists of a vertex shader and a fragment shader, also called the pixel shader. This one is for drawing the vertices, so these ones, and you can use it to change the shape a little bit, which I've done in some of the shaders. And this part, the pixel shader, is used for the actual painting. It's the one we're gonna use most of the time. So now that we've let's set this back. Now that we've created a shader, we're gonna apply that shader to the material we just created. So we're gonna choose the waterfall shader over here, and we're gonna apply this material to the quad. You don't see any difference right now, but if we start to create a variable, a color, let's call this watercolor, and we're gonna attach that to the base color. This value is gonna be exposed, so we can change it from within the material. If you now save it, you will see that this turns black because we choose a default color of black. But you can now open the material and change the color to anything you like. So water should be blue, so let's change the default color to blue as well. Okay, but this doesn't look like water yet. So the next thing we're gonna do is add some simple noise. Create a noise node, simple noise. And if we attach this to the base color, you'll see it looks completely different. But that's also not what we want. So what we actually want to do is to add this noise to the watercolor. So create an add node and add the water and the noise together, the color and the noise, to create this. So that looks more like water already. But this water should also be moving. Therefore we're going to use a time node. And we're also gonna want to change the speed of the movement of the water. So let's add a variable called foam speed. Let's set it to 1 for default, and it's gonna move, by the way, in the y direction. So we're gonna input this in the y part of the of a factor 2. We don't want to move in the x position because water is falling down, it's not falling sideways. And now we're gonna multiply the time, put it in slot A or B. It doesn't really matter for multiplying, so we can swap these around if you want, but it does matter for minus and for divide, but for multiply and add, of course, it doesn't matter which one you put first. So this is a very common construction where you multiply the time by a certain value to control the speed. And then we need another node called tiling and offset. That's a very useful node which you can use to change the offset, which you can use as an input for UV. And now we see that the water is really falling, or at least the noise is moving, and you have an effect like water is falling. So already looks a lot better. We can change this scale to make smaller or bigger water. I think this looks nice. So let's turn that into a variable as well. Let's call it foam size, and let's make it a default of, let's say 30 or something. Yeah, looks okay. Another thing you can do is to make sharp edges on the dark and light spots. You can do that by using a power node. Put this in slot A and use this output instead of the old one. Now if you change the power, you will see that because of the power, the white is becoming really white and the black is becoming really black. So you have like sharp edges on these values. So let's set this to 3 by default, and let's call it foam strength. So this is nice, but I want to add an extra touch to it. So what I'm gonna do is I'm gonna use a texture. I've already created a few textures in the waves folder. So let's see how you can add a texture to the shader graph. We're gonna create a variable, texture 2D. Let's call it highlight texture. And to use that, you need to use a sample texture 2D node. And now if we attach that to the color instead of the noise, and we set a default texture, you will see that the texture is applied to the shader. Over here you don't see it yet because we've already created this material before this default texture existed. So you still need to set it manually here if you want to show it. You need to select it over there. So alright, so we want to make this texture also moving. Well, therefore we can copy the logic we created here. So everything until the tiling and offset part. Can put that over here. And if you use that, you can also make the texture moving like that. This foam speed, let's change that variable to highlight speed. Set this to a value of a little bit less, let's say 0.4. And now we can copy this part and multiply these two to get a nice effect. Now you don't see any difference yet, but if we just change the texture or the speed, let's create a second highlight speed value. So this one is set to 0.4. This one should be different value, 0.2. We can also choose to use another texture over here, but if you change the speed, you already get this nice effect. I'm also gonna change, I'm gonna move this a little bit, let's say 0.1 and this one minus 0.1. So now they move a little bit sideways, both in different directions, and you get this. So now what you can do is put this into a power node again. And also create a highlight strength. By the way, if you use power, you can get big values, which will sometimes give strange artifacts. So what you can also do here is to clamp the value between between 0 and 1. So here you see that pink, that's because the value is having a weird value, and with the clamping things get better, but this value should also not be 0. The power should be like 0.5.1, or actually above 1. We can change the type to slider, so we can keep the value between, let's say, 0 and 20, and the default value is gonna be something like this, I think. Again, 4 gives a nice result. And we can also create a color for this highlight. Let's call it highlight color, and we can multiply this value with the color, so the color will be only visible in these parts where it's white. So if we multiply this and we choose a color, for example blue, you will see that you get blue highlights, but we want to use white highlights. And we can now also change the color to HDR and to increase the intensity, so this will give us also a better look. And now we can finally add this, let's organize this a little bit. we can add the highlights to this. And now you have like the foam and some kind of parts where it's like shiny. And if you save this and go back to the scene, we probably want to use the default values, so because they are nicely tuned. So let's create let's create this material again. Using the shader, and now it gets set to the default values, and you see here the final result. So if you want to copy any of these shaders that I put in this project, you can simply copy the two .shader graph and the .shader.meta file to your own project, and you can then open the shader. Sometimes you'll need the default textures, but they can also all be found inside this project in the assets. One more thing I wanted to show you is that in the force field shader I've created this print debug value function. You can copy it by Ctrl C, Ctrl V, and you can use it to do some debugging. Then you need to create a UV node, connect this to the UV node, and then you can watch any value. So for example, now you understand what this time node is doing. It's just outputs the time, which is increasing, and that we are using to make the movements. We could also, for example, see what goes into this UV input over here. So if I connect that, see that it is a value that's now decreasing, and that's the X or Y value of this of the offset of this texture. If you first split it, you will see that in the R and B slots, the X and Y coordinate of the offset of the texture are stored. So that's the UV values. This concludes the tutorial. I'll probably be updating the shaders in this project every once in a while. So if you have any feedback, please let me know.